Alright guys, welcome to the first video of the year. Lesson 1.1 talks about variables and expressions. Objective for today: after this lesson I will be able to write algebraic expressions. So in order to be able to write them, we better find out what they are. So we got a little bit of little warm-up activity here, and then we'll get into some definitions. So consider the population of Florida, the area of Colorado, and the flight time from Philadelphia to San Francisco. Which of these has a value that varies? Okay, so I got the population of Florida, the area of Colorado, and the flight time from Philadelphia to San Francisco. And really, I want to know which ones vary and which ones stay the same. So vary meaning that they would change. Well, the population of Florida certainly changes. You can gain more people or lose people. The area of Colorado, well, the borders around Colorado aren't going to change, so that's pretty much stuck. So that stays the same. It's constant or consistent. And the flight time from Philadelphia to San Francisco, well, as I fly, it could depend on wind speed, or it could depend on the weather, and all kinds of stuff like that. Depends what kind of plane you're in. So those things definitely vary. So population of Florida changes or varies. Area of Colorado stays the same, is consistent, and flight time would definitely vary. All right, so hopefully you made a little note of those. And here we go, moving forward. A little bit of definition and some terms we want to be familiar with. A mathematical quantity is anything that can be measured or counted. Some quantities remain constant, which means that they don't change. They never change. So something that's constant is always the same. It never changes. Other quantities change or vary, and we call those variable quantities. All right, so things that are changed, we call them variable because they vary or change. Anytime you see this little symbol in one of these videos, this is, kind of like the key understanding for the lesson. So our essential understanding is algebra uses symbols to represent quantities that are unknown or vary. You can represent mathematical phrases and real-world relationships using symbols and operations. All right, and that's like the whole basis behind algebra. A variable is a symbol, usually a letter, that represents the value or values of a variable quantity. An algebraic expression is a mathematical phrase that includes one or more variables. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. So if I have variables in it, we call that an algebraic expression. If we don't have any variables, then we only have numbers and plus signs and minus signs and things like that, operations, and we just call that a numerical expression. All right. Problem 1, writing expressions with addition and subtraction. So the first example, 32 more than a number. So more than means plus or addition. So I have n plus 32. You could easily write it as 32 plus n. Either one is acceptable. 32 more than a number. So to me, once I have this number n, I would add 32 to it. So I would probably write it this way, but this one certainly is correct also. B, 58 minus a number n. So I'm going to take 58 and subtract it from 58 minus something. So 58 minus a number n would just look like 58 minus n. Okay, so you're like, well, can I flip that around? Can I make it n minus 58? And you certainly can't when you deal with subtraction. The order is really important. With addition, it doesn't matter, the order, but when you deal with subtraction, the order certainly does matter. Because you would get two different answers depending on which one you used. If n was a number like 10, this would be a positive 48, but then you would have a negative 48 here. So since you don't get the same solution when you plug in a certain number for n, they're not the same, they're not equivalent. So that second one doesn't work. I have to take 58 minus a number. So 58 minus a number. C is close to B, except for the fact that it says 16 less than a number n. 16 less than a number n. So I have to have that number n first and then take 16 off of it. So that expression would look like n minus 16. Okay? Again, the order is important with subtraction. If you wrote 16 minus n, that would not be correct. All right. Throughout these sheets, you see these got it questions. So as we do a little bit, then we're going to give you a second or two to try it and practice. All right. So any of the got it's, go ahead and give those a shot. All right. So if you need to pause the video in order to do that, you can pause the video and go ahead and do that, or you could come back to them at the end. All right. As we proceed, writing expressions with multiplication and division. So 8 times a number, that's a multiplication problem. There's a lot of ways we can write multiplication. 8 times n with an x symbol. 8 a dot and an n. 8 times n, that's kind of what you see on the calculators these days. Or, you know, most of the time you just jam it together and make it 8n. Whenever things are jammed together, it means multiplication, 8n. All right, this is probably the least desirable one, because once we start putting x's in here, then we might think that they're variables. So let's try to stick with, you know, 8n or 8 times n or 8 times n, written either of those ways. All right, quotient is division, the quotient of a number and 5. So I'm going to divide n divided by 5. Probably even better is n over 5. Remember, this is a fraction. A fraction bar represents division, n divided by 5. The quotient of n and 5. 1/2 of a number n, so n divided by 2. If I take half, I divide it in half, divided by 2. Or n over 2, n divided by 2. Remember, that little line in the middle of a fraction means division. Okay? So a couple more got it's that you can give a shot to. So go ahead and pause the video and give those a try. And we'll check those up tomorrow, make sure we're okay. All right, as we proceed, problem 3. Now I get a couple things going on. So I get 2 operations, or maybe more. 3 more than twice a number x. So twice a number x, well, that would be 2x. And then I want to add 3 to it. So I got 2x plus 3. You could certainly write 3 plus 2x. However, when I read this problem, 3 more than twice a number x, I better have that before I can add the 3 to it. So I would probably write it like that. But again, with addition, the order doesn't matter. So the second choice here is also acceptable. 9 less than the quotient of 6 and a number x. Well, quotient means division. So 6 and a number x would be 6 divided by x. And then I have to take 9 less than that. So I have to have my thing, my 6 divided by x, and then take the 9 off of it. Letter C, the product of 4 and the sum of a number x and 7. The product of 4 and this whole thing. So sum means addition. X and 7, well, x and 7, I better add those together. And then I'm going to multiply the whole thing, product, multiply the whole thing by 4. So by putting this parenthesis here, I ensure that I do the x plus 7 first, get a number, then multiply it by 4. Okay? Some more got it's there that you can give it a shot to. Pause it if you need to. And whenever you're ready, come on back. Problem 4. Using words for an expression. What word phrase can we use to represent the algebraic expression 3x? Well, when the 3 and the x are jammed together, we just said that means multiplication. So 3x means 3 times x, or the product of 3 and a number x. All right, so pretty straightforward. Just go in the opposite way that we did in problems 1, 2, and 3. So go ahead and give those got it's a shot. Pause it if you need to. All right, problem number 5. We're writing a rule to describe a pattern. Okay, the table below shows the height above the floor of a house of cards depends on the number of levels. So here's my table, 24 inches high, and then each level of cards is 3.5 inches. All right, so from that info, here's what I need. The table height is 24. Each card is 3.5 inches, so that each time I add a level, I'm adding one more card to that level, so I'm really adding 3.5 inches. If I look in the table here, when I have 2 levels, really what I had is the 3.5 for the first level, 3.5 for the second level, plus the 24 for the table. All right, and that's the same as 3.5 times 2 plus 24. When I get another level on there, well, now I got 3.5 plus another 3.5 plus another 3.5 for that third level plus the height of the table. That's the same as 3.5 times 3 plus 24. Same follows true for level 4. There's 4 of these 3.5s. So an easy way to write that would be 4 times 3.5 plus the original 24 for the table. So hopefully what you can see from this table here is that each time I add another level, I'm just going to add another 3.5 on there. All right. So for any number of levels, when I had 4 levels, I had 4 3.5s. When I had 3 levels, I had 3 3.5s. When I had 2 levels, I had 2 3.5s. So for any number of levels, I just need that many 3.5s. And then I would add the 24 on there for the table. So the number of levels times 3.5 plus the 24. All right, that was an algebraic expression. 3.5 times the number of levels plus 24. Okay, great. You could also write it like this, 3.5 times the number of levels. So I just jammed it together there instead of using the little star. All right, so just jam it together. 3.5n plus 24. Try to clean it up as much as you can when you can. Great. A group of students built another house of cards that had 10 levels. Each card was 4 inches tall, and the height from the floor to the top of the house of cards was 70 inches. How tall would the house of cards be if they built an 11th level? Well, what do we know? We know that there's 10 levels right now. We know that each level is 4 inches. We know that the height from the floor to the very top of the house is 70 inches. And I'm just going to add one more level onto the top. Well, since each level is 4 inches, I would just have the 70 that I'm at right now, plus another 4 inches, a grand total of 74 inches. All right, pretty easy. Another group of students built a third house of cards with n levels. Each card is 5 inches tall, and the height from the floor to the top of the house of cards was an expression here, 34 plus 5n inches. How tall would the house be if the group added one more level of cards? Okay, well, what do we know? There's a certain number of levels that it has. We know that each level is 5 inches. We have an expression, an algebraic expression for the height from the floor to the top of the house. And I just want to add another level of cards. Well, since each level is 5 inches, if I'm going to add another level to that, well, then I'm at 39 plus 5n. Okay? Right here in C, I gave you a little table. It shows the cost of renting a scooter depends on how long the scooter is rented. Fill in the missing rows of the table. Write a rule. Give the rule in words as an algebraic expression. Okay? I'm going to let you try that. So fill in the rest of the table. Write a rule and give the rule in words and also as an algebraic expression. We'll check that up next time. Here in D, all right, I got another table for you. So I invite you to read that one also. And we're going to look at that one in the next class. So you do not have to do D for homework. We're actually going to start class by looking at D. All right, so please make sure you've done all the try-its, and you've also done question C with the table of renting the scooter. All right, and then any questions you got, I'll see you next time. Peace.